Imagine an apartment building where a single tenant leaves a bicycle in the hallway, violating the fire code. Now imagine that the landlord's only available solution to clear that hallway is completely demolishing the entire building. That disproportionate response describes exactly how global internet security teams have historically been forced to handle malware and abuse. To remove a single threat, they often have to take down an entire network structure. This diagram of the domain name system architecture shows why. The entities that manage web addresses, registries, and registrars operate almost exclusively at what is called the second-level domain. To enforce rules, they rely on status codes like client hold or server hold, which essentially suspend operations at that specific second-level junction. But here is the architectural flaw. If a cybersecurity team spots a tiny, localized threat, a single malicious subpage, they cannot target it directly from the top down. The only lever they can pull places a massive X over the entire primary domain, instantly severing the connection to every other subpage, subdomain, and email server attached to it. Stopping a localized cybersecurity threat inherently breaks the architecture of the internet for that specific network. The threat is neutralized, but it results in total, widespread inaccessibility. We have to distinguish between two distinct types of threat targets. First, you have malicious registrations, which are domains built exclusively by bad actors to cause harm. Then you have compromised legitimate domains. These are innocent, everyday websites that have been quietly hijacked. When registries use broad suspension tools on those compromised legitimate domains, innocent users get caught in the crossfire. Legitimate business infrastructure is wiped offline, and medical or civic emails fail to route. And perfectly legal speech hosted on shared infrastructure is instantly silenced through overblocking. Global internet governance is currently trying to solve this specific tension. The goal is to find a way to surgically neutralize automated threats without stripping away innocent users' digital rights and access to due process. In April 2024, the rules governing how the internet responds to these threats were rewritten. The system moved away from relying on voluntary industry best practices, replacing them with legally binding contractual obligations that require providers to take prompt action against verified abuse. With these strict rules in place, investigators needed new tactics that avoided blunt domain suspensions. The first major evolution in this toolkit is a mechanism known as associated domain checks. Moving from a reactive per-domain model to a per-registrant accountability model, websites are grouped by registered account. When an investigator verifies abuse on a single domain, the system traces that connection back, instantly flagging the actor's entire portfolio. This strategy targets serial abusers by identifying their entire footprint. By mapping out the underlying accounts, investigators can disrupt broad, coordinated attack campaigns simultaneously, rather than playing an endless game of whack-a-mole with individual domains. While mapping out active portfolios helps clean up live abuse, security teams are also moving upstream, aiming to stop the deployment of abusive infrastructure before a domain is ever fully registered. This introduces the second major policy update, the proactive friction model. That actors rely on high-volume registration tools, APIs, to instantly buy thousands of web addresses at once. Proactive friction restricts bulk API access for new customer accounts. Those limits stay in place until the account establishes a baseline level of trust or verifies their identity. Forcing malicious bots to slow down acts as a direct technical countermeasure. It starves automated attack campaigns at their source, bypassing the need for broad DNS-level suspensions later on. Despite these new contractual rules and proactive tools, policymakers are still facing a roadmap of significant vulnerabilities. The Governmental Advisory Committee tracks these as policy gaps. The most glaring loophole currently identified is Gap C4, subdomain abuse. This diagram maps a jurisdictional blind spot. The second-level domain is regulated, but the connected subdomain zone operates outside global rules. Without binding policies, teams cannot target localized abuse. Mitigation hits a jurisdictional wall, forcing a block to drop on the entire parent network. Until subdomain providers are brought into the governance fold, either through future contracts or standardized best practices, the internet's backdoors remain wide open to exploitation. Closing these gaps requires standardizing how abuse is reported across a heavily fragmented global ecosystem, and that requirement has sparked a fierce institutional debate over how to enforce the rules. This split-screen illustration highlights the two competing visions for the Internet's future. On one side is a proposed Common Abuse Response Facilitator, or CARF, a centralized hub designed to process and standardize evidence. On the other side is a reliance on decentralized, voluntary, industry-led alternatives. Critics fear voluntary networks lack accountability to ensure compliance. However, a centralized mandate challenges the decentralized architecture that defined the naming system's massive growth. Securing the DNS has evolved into a strategic challenge. The long-term stability of the naming system now depends on aligning rapid security responses with the legal protections of the individuals who use the network.